Welcome to this video, guys. um, in this video we are going to see how to work with proteus professional 8. Yeah. um, Firstly, starting with how to open a new simulation, that means new simulation area. Mm, we can use that means we can open the proteus software and click on ISIS here, schematic capture. Yeah, we need to open this and you will get a PCB like structure, um, where you can place the components and also wire it. Okay, let's see an quick example so you can understand all things. Mm, first, mostly we need to know where the components should be taken and where we can place other components, like virtual, for example. These are the virtual components where we can take this, that means oscilloscope, logic analyzer, counter timer. We will use most of the voltmeter, ammeter, along with this only, virtual components only. Next, uh, yeah, generator means input generator, where we use DC, sine, pulse, exponential, etc. Yeah. After this, terminals in this we use input, output, power and ground. Most power and ground only mainly used proteus. Yeah, proteus component. That means in terminals we use power and ground mostly. So we can go to the quick example, where we are using an LED, interfacing LED with the 8051 microcontroller. Yeah, let's move. To place the components, we need to use right click. That means right click in the PCB area or the simulation area. This is the simulation area where we need to place the components, that means the square form. So we need to place components, and from libraries, in this we need to type the code, that means AT89C51. Yeah, this is the 8051 microcontroller. Let's take this and place here. Yeah. In the components tab you can have you can able to see the components you place in this simulation area, so you can visualize it. Next, we need to place an LEDs, under to drag, that means we need to place the LEDs here, so we need to drag this slightly left, so we can click it and drag this, or else you can right click and you can have the drag object option also. You can delete object, and you can that means you can rotate it as wise, that means while going to capacitor and all, you can see, visualize it. Yeah. Next, we need to place an LEDs. LED, we have many LEDs. We can take red. Okay, and after clicking, you can able to see the LED red. That means that is selected in the components tab. So you can click on the So we can place it. We are placing 8 LEDs. Yeah. After this, we need to place resistor. That means when we place a LED, we should place a resistor. It is a rule, that means pull up and pull down resistor must be placed, else the LED will burst off. Yeah. By selecting the resistor, we have active resistors and assembled resistor. That means where we can, this is most commonly used resistor. Active resistor means the resistor type will be highly active. That means for a real-time environment we can use active, but for simulation we can use this only. Yeah. uh, Here we use, that means clockwise, so we can place this here clockwise. So yeah, it is ready. We need to give an output no, that means power no. So we need to place an clock. To place an clock, we can take an crystal oscillator. So yeah, quartz crystal. We can see more number of components. If you start with an that means if you start with an basic example, you can know how depth is proteases, and it is useful to your projects and all. So you need to learn more with proteus. So be a connect with proteus. That means always, yeah, osmoles and actives. Active means like this, it will used to measure an active real world capacitance. So we can use a simulation only. In further videos, we will, yeah, yeah, put a detailed explanation about more and more simulation in Proteus. As a start, we start with the basic. So don't worry if you don't know anything about proteus. mm, yeah, we need to place an capacitor and a resistor, and we need to give an power element. Power element can be selected in terminal also, terminal and power. So place a power element, that is VCC, and it should be grounded, no, yeah, else it will flicker out. Yeah, that's all. We need to connect with a wire. uh, yeah, when you see here, when you move here, so it will show us a red color dotted symbol. So where you can select that and move along with the path. And to move for see this to move further or right or left, you need to click on that path and move there. So that's all. If you need to select, that means if you are selected a wrong wiring, then you need to right click it so it will disappear. Yeah, and we need to give an power supply to the LEDs also, else LED will just be a toy. Yeah, I am showing how we need to do a simulation in Proteus. So I am not cutting any of the video. That means I am showing full video what I am doing without any cut. Yeah, we are connecting it with the port 2 because we are written program from port 2. For this also we need some presentation skills, because if this wiring looks uglier, that means it is not uneven, then a new person cannot understand this. So we are changing the resistor value. If you put 10k, then LED will not glow. So we are putting 280. This is the resistor value where we can calculate it. How to calculate that means I will share another video how to calculate the resistance value, so don't worry. Please, this is the video that explains the how to work with proteus. So I concentrating on that only, so don't worry. If you know how to calculate the resistor value also, I will put it in another video. Yeah, and the capacitance also we need to change here in clock 33 picofarad. That's it. Our implementing of LEDs with 8051 diagram is over. Next we move to program. In program we use the Kale version, that is Kale, to generate the hex file. So we written the program, C program, and added it. I will show this in another video how to program an LED, that means program 8051 using Kale. So don't worry how it came. So I got the hex file, so I need to fix it here. So double click the microcontroller and click on this icon, that means folder icon. So where you can add this, I have it in proteus, sorry, yeah, here, not there. Yeah, here, object. Yeah, dot hex file will be always in object file. Therefore clicking OK, then you can play this. That means you can run the simulation here itself, clicking on this play button, or else you need to debug here and start debug. And after here you need to run this. Yeah, it start to blink with a delay. So our implementation is correct and we got the result. So this is how we need to simulate a circuit. So thank you for watching. If any doubts, mention your doubts in comment. So I see you with an interesting and another video, interesting videos. So bye.